Thermoset and thermoplastic insulations possess distinct properties which lead to varying levels of durability. Thermoset insulation, such as Type W and Type G, exhibits higher heat resistance compared to thermoplastics. This makes it more suitable for harsh environments like marinas where temperatures can fluctuate and potentially reach elevated levels. Thermoset insulation also demonstrates improved chemical resistance. It is resistant to a wide range of chemicals, including salt water, which is a prevalent element in marine applications. This resistance protects the wiring from degradation and corrosion, contributing to a longer lifespan. However, thermoset insulation typically offers lower flexibility than thermoplastic insulation. It tends to be stiffer, which can make it more susceptible to damage during installation, especially when navigating tight spaces or complex pathways. Thermoplastic elastomer, or PP, insulation presents a different set of characteristics. It offers moderate heat resistance, which is generally adequate for marine applications but not as high as thermoset options. A key advantage of PP insulation is its excellent flexibility. This makes it easier to handle and install, particularly in confined areas where bending and maneuvering are necessary. PP insulation also has good chemical resistance, providing protection against many substances. However, its resistance to saltwater exposure might not be as robust as that of thermoset insulation. For marina wiring, the recommendation leans towards Type W thermoset insulation due to its superior heat and chemical resistance. The enhanced durability of thermoset insulation contributes to a longer lifespan and better protection in the demanding marine environment. The selection of wire insulation should also consider several additional factors that can influence the overall durability of wiring systems in marinas. Cable construction plays a significant role. Shielded or armored cables provide extra protection against mechanical damage and electromagnetic interference. These cables are designed to withstand physical impacts and prevent signal disruptions, further enhancing the reliability of the wiring system. Conduit use is another important consideration. Conduit acts as a protective barrier for cables, shielding them from physical damage and exposure to extreme temperatures. The use of conduit can significantly extend the lifespan of wiring, especially in environments where cables are susceptible to abrasion, impact, or thermal stress. Proper installation practices are crucial for ensuring the longevity and reliability of wiring systems. Careful installation techniques, including maintaining appropriate bending radii and providing adequate cable support, are essential for preventing damage. Bending radii that are too sharp can cause stress and weaken the cable, while insufficient support can lead to sagging and potential damage over time. Furthermore, adherence to relevant electrical codes and standards is paramount. These codes and standards outline specific requirements for wiring installations, including conductor sizing, overcurrent protection, and grounding. Compliance with these regulations ensures the safety and proper functioning of the electrical system. The National Electrical Code, or NEC, is a widely adopted standard that provides comprehensive guidelines for electrical installations. It covers various aspects of wiring, including conductor types, ampacity ratings, and installation methods. For example, NEC Table 310.15b16 provides ampacity ratings for various conductors based on their size, insulation type, and installation conditions. This table helps ensure that conductors are properly sized to carry the intended current without overheating. Additionally, the NEC addresses specific requirements for wiring in marinas and other marine environments. These requirements take into account the unique challenges posed by saltwater, moisture, and other factors that can affect the performance and safety of electrical systems. Grounding is another critical aspect of electrical safety. Proper grounding helps to prevent electrical shock hazards and ensure that fault currents are safely diverted to ground. The NEC outlines specific grounding requirements for different types of electrical systems, including those in marinas. Overcurrent protection is also essential for preventing damage to wiring and equipment in the event of a fault. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the appropriate size and type of overcurrent protection devices for different circuits. The proper selection and installation of these devices are crucial for preventing fires and other electrical hazards. Furthermore, regular inspection and maintenance of wiring systems are necessary to identify and address any potential problems. Inspections should be conducted by qualified personnel who are familiar with electrical codes and standards. Maintenance activities may include tightening connections, replacing damaged components, and testing the grounding system. By implementing a comprehensive inspection and maintenance program, potential problems can be detected early and addressed before they lead to more serious issues. When selecting wiring for marina applications, it is important to consider the specific environmental conditions and the type of equipment that will be connected. Saltwater exposure is a major concern in marine environments, as it can corrode metal components and degrade insulation. Therefore, it is essential to use wiring that is specifically designed for marine use and is resistant to saltwater. The type of equipment that will be connected to the wiring also influences the selection process. Different types of equipment have different power requirements and may require specific types of wiring. For example, high-power equipment may require larger conductors to handle the increased current flow. In addition to the factors mentioned above, it is also important to consider the cost of wiring. Different types of wiring have different costs, and it is important to select a wiring solution that is both effective and cost-efficient. However, it is important to prioritize safety and reliability over cost, as a failure in the wiring system can have serious consequences. In summary, selecting the appropriate wiring for marine applications requires careful consideration of several factors, including the type of insulation, cable construction, conduit use, installation practices, electrical codes and standards, grounding, overcurrent protection, inspection and maintenance, environmental conditions, equipment requirements, and cost. By taking all of these factors into account, it is possible to ensure that the wiring system is safe, reliable, and durable. When discussing thermoset versus thermoplastic insulation, it's important to also consider the specific types of thermoset and thermoplastic materials available. For thermoset materials, common options include cross-linked polyethylene or XLPE and ethylene propylene rubber or EPR. XLPE offers excellent electrical properties, heat resistance, and chemical resistance. EPR also provides good electrical properties and flexibility, as well as resistance to moisture and ozone. For thermoplastic materials, polyvinyl chloride, or PVC, is a widely used option. PVC is cost-effective, flexible, and resistant to many chemicals. However, its heat resistance is lower than that of thermoset materials. Another thermoplastic option is thermoplastic elastomer, or TP, which, as previously mentioned, offers good flexibility and moderate heat resistance. When comparing these materials, it's important to consider the specific requirements of the application. For example, if high heat resistance is required, XLPE or EPR may be the best choice. If flexibility is a primary concern, PVC or TPE may be more suitable. In addition to the insulation material, the conductor material also plays a role in the overall performance and durability of the wiring. Copper is the most common conductor material due to its excellent conductivity and corrosion resistance. Aluminum is another option, but it has lower conductivity than copper and is more susceptible to corrosion. When using aluminum conductors, it's important to use connectors and terminals that are specifically designed for aluminum to prevent corrosion and ensure a reliable connection. The size of the conductor is also an important factor. The conductor size must be sufficient to carry the intended current without overheating. The NEC provides tables that specify the allowable ampacity for different conductor sizes based on the insulation type and installation conditions. It's important to consult these tables to ensure that the conductor size is adequate for the application. Furthermore, the installation environment can significantly impact the performance and lifespan of wiring. In harsh environments such as marinas, it's important to take extra precautions to protect the wiring from damage. This may include using shielded or armored cables, installing wiring in conduit, and providing adequate support to prevent sagging and abrasion. Regular inspections can help identify potential problems early, allowing for timely repairs and preventing more serious issues. These inspections should include checking for signs of corrosion, damage to the insulation, and loose connections. Any issues that are identified should be addressed promptly to maintain the safety and reliability of the wiring system. In addition to the technical aspects of wiring selection and installation, it's also important to consider the regulatory requirements. Electrical work is typically regulated by local, state, and national codes and standards. It's important to be familiar with these regulations and to ensure that all electrical work is performed in compliance with them. This may require obtaining permits, hiring licensed electricians, and undergoing inspections. Compliance with regulatory requirements helps to ensure the safety and quality of electrical installations. In summary, selecting and installing wiring for marina applications requires a comprehensive understanding of materials, design, installation practices, and regulatory requirements. By carefully considering all of these factors, it's possible to create a safe, reliable, and durable wiring system that will provide years of trouble-free service. Remember to always consult with qualified professionals and adhere to all the applicable codes and standards to ensure the safety and proper functioning of electrical systems.